Hey, happy Monday. We are not going to turn in our section 6.1 work. We're going to continue section 6.1 today. Add to it. We'll hand it all in tomorrow when I am back. So section 6.1 continued, solving nth roots still. So far what we've been doing is we've been looking at unusual roots. Remember we made that big chart on Friday and we would take 4 to the 5th power, or we'd 6th root, some really big number like 128 or something. We're going to use that chart that we made on Friday to solve equations today. All right, so remember that when you're actually solving, you're getting the x all by itself. You're getting the variable all by itself. Now what that means on the graph is that we're finding the x-intercepts if the equation equals 0. And we always set the equation equal to 0 to start. If we don't set the equation equal to 0, what you're actually finding is where the two equations intersect. Don't want you to worry about that too much right now. I'm going to show you an example of that later on the graphing calculator. All right, so to review, we've been finding weird, unusual roots, and we're going to use those today to solve. All right, so let's review. Remember on Friday how we would find 3 to the 3rd, and we do this without taking 3 times 3 times 3. If you use your chart where you have those numbers, you'd find the 3 here and the 3 here, and then where those two numbers come together is, well, 3 to the 3rd is 27. So this equals 27. So how can we use that to solve a problem? Right, so now the problem becomes solve x cubed equals 27. Solve that. What it means to solve is to figure out what x equals, all right? We want to do that. We want to figure out what x equals. So don't we have to get rid of this little 3 right here? We've got to get rid of it, okay? How do we get rid of a cube? What we could do is cube root it. Not square root it because it's not a square, it's a cube root. So we're going to cube root that side and it'll just give us an x. But if we do it to that side, we have to do it to this side. So I cubed root the left side, I cubed rooted the right side. Now what I'm going to do is use my chart, and since this is a cube, I'm going to go find the 3, see if I can find a 27. Oh yeah, 3 to the 3rd is 27, and so that means that the cube root of 27 is 3, and that's our answer. 3 to the 3rd is 27, so we're using our chart to solve. Now, do remember that when we were doing this before, whenever we square rooted, remember how we'd have to put the plus or minus sign? I didn't do that on that last example. You notice how I didn't put a plus or minus? You must use the plus or minus key anytime you take an even root. It has to be even. So why? Why does it matter that it's even? I'm going to show you. If we take 2 cubed, that's 8. If we take negative 2 cubed, that's negative 8. All right, so let's do another one. What about 2 to the 4th? 2 to the 4th is 16. Well, what's negative 2 to the 4th? Whoops, having trouble here. Negative 2 to the 4th. Negative 2 to the 4th is still positive 16 because a negative times a negative is positive, and then times another negative is negative, and then times another negative is positive. So anytime your power, this power right here, anytime it's even, you notice how it doesn't matter whether it's positive or negative. If you take it to an even power, it's going to be positive. Odd numbers like these odd numbers, it is unique. This is a positive 8 and this is a negative 8. So what you need to remember is anytime that your power or your exponent is even, that means you plus or minus. If the power or the exponent is odd, you do not have to plus or minus. So let's do another example. This one says evaluate 3 to the 4th. So use your chart. What is 3 to the 4th? Is it 3 to the 4th, 81? Okay. Now if that's true, that 3 to the 4th is 81, now let's do the next example. The next example says solve x to the 4th equals 81. Well, how do you get rid of, if we want to solve of x to the 4th, how do we get rid of this little 4 right here? What we would have to do to get rid of it is 4th root both sides. So if I 4th root that side, I have to 4th root this side. And we would use our little charts to find out the fourth root of 81, and we would see that the answer was x equals, this time we're going to plus or minus because 4 is an even number. It's your root or your power. So I'm going to come back up here. Power or root. If your power or root is even, then you have to plus or minus. We are not using our calculators right now. We're going to stick to our charts. Okay? All right, let's move on. So let's try some more examples. Right, these are just all more examples. We're going to solve, and on the places where it's not on our chart, we're going to use the calculator. If it's on our chart, we're going to use the chart. And we're on our next test that we have, there'll be both a calculator and a no calculator part. On the no calculator part, you will be able to use your chart. All right, so we're going to solve these. Round your results to the nearest 3 decimal places if I need it. Okay, the first thing that we want to do to solve these is to get the x by itself. First example says 4x to the 5th equals 128. We want to get the x by itself. So let's first divide by 4. And so we have x to the 5th equals, let's see, this would be 32. Now, if we want to continue to get the x by itself, we need to get rid of that 5. And so we 5th root both sides. We 5th root both sides. And I do not need a plus or minus because the 5th root is odd. And now we use our chart. And we go look on our chart and we find a 5 and a 32. And we go, oh, that answer is 2. So the answer is x equals 2. Next example. This says quantity, parentheses, x minus 3 to the 4th equals 21. We did these with squares. We cannot add the 3 first. We cannot add this 3 right here. We can't do it yet because this guy is in the way. So what we need to do first in this case is 4th root both sides. All right, the reason that we're doing that is because the 4th is on the outside. So when we 4th root both sides, this and this cancel each other. So now we have x minus 3. And over here, we have the 4th root of 21. If I go to the 4th root of 21 and I try to find 21 on the chart, this is one that is not on my chart. So we hopefully Friday learned how to do this. If not, I'm going to show you real quick. On your calculators, you have an nth root button. Your graphing calculators, it's under the math menu. See how it's number 5? On your scientific calculators, it may just look like a y to the x button. Let me show you over here. It might look like this button somewhere on your calculator. It might also look like this button. Hopefully we practice that on Friday. So let me go back to the graphing calculator. We want to take the 4th root of 21. I'm trying. Here we go. Here it is, 4th root of 21. And so I go under my, I go under my math menu. And it's number 5, but I forgot. Oh, I need to enter the little 4 first. So I enter 4, and then I go hit that button, math 5, and do you see how it actually made a 4th root? And now I enter in 21. When I hit enter, it says 2.14, and I'm going to round that to 1, 2.141. And so right now my answer is 2.141. Now, do I need to plus or minus? Correct. You need to put a plus or minus there because 4 is an even number. And now my last step is to add 3. Now this seems a little bit strange to me because I'm adding 3 to 2 numbers. I have 2.141 plus 3, and I have negative 2.141 plus 3. So I have to do both of these. So when I do that on my calculator, I hit 2.141 plus 3, and I get 5.141. And when I do, let me come back to here, negative 2.141, negative 2.141, and then I add 3, I get 0.859. So let me come back here, and I have 2 answers, 0.859. So I had to plus or minus here at this step. Right when I 4th rooted, I had to plus or minus. And so then when I added 3, I had 2 numbers to add 3 to, positive 2.141 and negative 2.141. Okay? So the ones with the parentheses are always going to be a little bit harder. Let's look at this last one. x cubed plus 10 equals 3. So if I want to get this x by itself, the first thing I need to do is subtract 10. All right. Now I have x cubed equals negative 7. And now I'm going to cube root both sides. So I cube root this side and I cube root this side. Oh my goodness, can we cube root a negative? Yes, we can, because it's odd. You can actually punch that in your calculator. Even though this is not one we have memorized, it's not one on our chart, we can take the cube root of negative 7. So let's go back to the calculator and remind ourselves how to do this. All right, so here I am, and I want to cube root negative 7. So I enter 3, and then I go under the math menu, and I do that, which is this guy. So I made a cube root, and I'm going to cube root negative 7. And then when I hit enter, I get negative 1.913-ish. So negative 9 point, oh, what was it? Negative, I forgot already. Let me go back. Negative 1.913. Okay, negative 1.913. Negative 1.913. And I didn't need to plus or minus because it was odd. All right, so you want to get the x by itself. You want to undo by cube rooting or fourth rooting or fifth rooting. Use your calculator if it's not on your chart. And I want you to just do the best you can. Please try to help each other. I wanted to show you one thing on the graphing calculator. I'm going to take this one that says let's do x cubed plus 10 equals 3. So I just want to show you something on the graphing calculator real quick. You don't need to worry about this, but I'm going to show you. If I go here to the y equals and I do x cubed plus 10, all right, plus 10. And if I put that there and I put the 3 here, see how I have this is an x plus 10, this is x plus 10, and this is a 3. So I have an x cubed plus 10 and a 3. So if I go back to the calculator, I enter those each on one line, and I'm going to hit graph. They crisscrossed each other. And I'm not going to worry about you doing this right now, but if I go to figure out exactly where they crisscross, there's a way I can do that on my calculator. I can figure out where they intersect. And when I do that, I'm just going to go do it real quick. It says, look what the answer is on the graphing calculator, negative 1.913-ish, and that's what answer we got. So it does work. I mean, there's a way to do it on the graphing calculator too. And because, you know, we don't all have the graphing calculators, I'm going to wait till I get back to worry about that too much. Those of you that do have one, I would love to show you so that you can use it. All right, so we're going to solve though algebraically today. We're not going to worry about doing it on the graphing calculator. You can do it just by using your calculator to calculate something. So there you go. There's your assignment for today. Just add right to it, and all you're doing is 50 through 58. Do them all. There's not a whole lot of them, so please give it your best effort and help each other out. Have a great day. I will see you tomorrow.